Hello, everybody. Today, my name is Rishi, and today I'll be solving Deep ML problem number 6, calculate eigenvalues of a matrix. So, our task is to write a Python function that calculates the eigenvalues of a 2x2 matrix. The function should return a list containing the eigenvalues, sorting the values from highest to lowest. So our input is a tensor already, and we have to output a tensor with the two eigenvalues highest to lowest. They provide an example of 2, 1, 1, 2 with eigenvalues output of 3.0, 1.0. So to get started, let's map this out via comments. I don't think we need a flowchart for this. It's a pretty simple function. So to get started, we need to find the eigenvalues. Second, we need to sort highest to lowest. And lastly, we need to return the sorted eigenvalues. So, how do we find the eigenvalues? There's this very useful Python function in torch.linalg for linear algebra called Eigenvalues. So torch.linalg.eigenvalues, and we input the matrix, and this gives us the eigenvalues. So it gives us the eigenvalues. Okay. Now, how do we sort from highest to lowest? So you might think torch.sort will work, and it will. So what torch.sort does, though, it returns the sorted values, and it also returns the indices. So sorted values, comma, indices, because it's two things being returned in a tuple, equals torch.sort of x descending equals true, because we want it to go from highest to lowest, so it must be descending. However, if we run this, the code will error. Well, let's put return sorted values. Still, the code will error. The reason why is that eigenvalues sometimes can be complex numbers, and we can't sort imaginary value. There's no value to sort there. So to remedy this, we can put x through torch.real. What torch.real does is that it returns a tensor of only the real values in the input matrix X. So with that, we can submit and see that this will meet all the test cases, I believe. Yep. And it solves all test cases. So test case 1, 2003, same output. Test case 2, 0110, same output. And test case 3, 4213, roughly the same output, though we should have some rounding on the output on our second number in the list. But that's fine because the problem didn't say it, and it's still marked as correct. Okay. As usual, the code and the solutions are inside the GitHub below in the description. And yeah, thank you.